Hello everybody. In this video I will go through an example for chapter 11 which deals with linear regression, and this should be very helpful for you guys when you need to solve your activity 11. Okay, let's take a look at what we got. One of the primary feeds for beef cattle is corn. So the following table presents the average price in dollars for a bushel of corn and a pound of ribeye steak for 10 consecutive months. What we have here is a bivariate set of data. So we have corn price and then ribeye price for 10 months. And the main goal of this problem is to determine whether there is a linear relationship between these two things. Okay, so the first step in proceeding with this problem is taking this data and plug it into your columns. So let's go to stat, added, and all of my data is already entered. So you can see that in L1 I have prices for corn, in L2 I have prices for ribeye. All right, how do we make a scatter plot? We go to second Y, activate one of the plots. So let's go ahead and say on for the plot. This is the type. By default, it's going to say X list is L1, Y list is L2, so that's nice. And to plot this, we go to zoom 9. All right, that gives us an idea if these two variables are actually related. So to make a scatter plot for this data, what do I need to do? Okay, so let me go ahead and change my pen here. So I'm going to roughly sketch this graph. Let me see. On the x-axis I had my independent variable, or in statistics we're going to call this explanatory, and let's take a look at it. Corn price would be the explanatory variable, okay, and the ribeye price is the response, right? Because if the corn prices go up, it is reasonable to assume that the ribeye prices will also go up. Okay, so here we have corn price in dollars per bushel, and then here I have ribeye price in dollars per pound. Okay, so now I go back to my calculator and I roughly copied this. So let's see. So then there's 3 points here, just to kind of get an idea of what's going on. Okay, and then 1, 2, 3, 4 there. So okay, that's a rough sketch of your scatter plot. Take a look at it and I say, well, it looks like there is some positive, probably moderately strong linear relationship. Okay, now the next step is to compute the least squares regression line for predicting the ribeye price from the corn price. So what it's really asking us to do, it's asking us to find a line of best fit. So imagine if I were to find a line that goes through these points, and it's the best line as far as minimizing the errors between the line points and the actual point on the graph that we've gotten here. So this is what a least square regression line is. So we can try and figure it out what this line is on our own, but we don't need to. The calculator does it all for us. So how do we do that? Okay, let's go back to stat, and we're gonna go to calc and use command 4, and I'm gonna say L1 comma L2, and that will produce this equation right here. Okay, so what does it mean? If you take a look at it, this is a linear equation, which is what we want, and it has coefficients. A, think about it as a slope. So if you're used to seeing linear equations in this form, y is equal to mx plus b, that's fine. So that's what we say a linear equation looks like in algebra. In here, they just use a and b, which is really the same thing. So let's take a look. Our a is 1.83. So what is my equation? Y is equal to 1.83x plus, let me take a look at 1.45. That will go here. Okay, so this is the least squares regression line for predicting the rebuy price from the corn price, right? So your independent variable is the price of corn. Your dependent variable will be rebuy price. Okay, give the correlation coefficient. The correlation coefficient is a number that tells us how strong a linear relationship is. Okay, now your calculator is also able to produce this, but in order for your calculator to do this, we have to actually activate something, and we need to turn the diagnostics on. So we go to second catalog, and then press this button here, D, and that will bring you to the list of all commands that start with D. We'll find diagnostic on, turn it on, enter. Okay, so let me go through this again. Second catalog, D, find diagnostic, turn it on, and it's done. Now when we go back to stat, calculate linear regression, L1, L2, we get our coefficients over here. Okay, so we still get these coefficients for the linear regression line, but then also we get this coefficient R, and that's what tells us the strength of our linear regression. So this one is asking for 3 decimal places, so it's 0.878. R is equal 0.878. This tells you that your relationship is pretty strong. The closer it is to 1, the stronger the relationship is, and it's a positive relationship. The closer R is to -1, then the stronger the relationship is, and it's a negative linear relationship. Okay, explain in words what the slope of the regression line tells us. Okay, now remember, this is model and price, so what would I write here? I would write for every $1 increase in price of corn, the price of rebuy goes up, right? By what? This is my slope. By $1.83. Okay? This slope right here tells us the relationship between the two variables, and that's what it is. So if my price for corn goes up by $3, then the price of rebuy goes by 1.83 times 3. That's the interpretation of the slope. Okay, so that's what you write here. Then the next part is asking us to use the regression line model to predict the price of rebuy if the price of corn is $6.45. Okay, so what am I really asked to do here? I'm going to do y hat is 1.83 times, let's see, 6.45 plus 1.45. Okay, if the price of corn is $6.45, how much is rebuy per pound? So let's go back to our calculator and plug this in. So 1.83 times 6.45 plus 145. Okay, so let's see, what do we get? Well, since this is in dollars, right, it's reasonable to assume it's $13.25. Okay, so $13.25. that is the price of rebuy per pound if the corn price is $6.45. Now let's take a look at the table. Do we actually have a value for rebuy price with 645? And the answer, yes, we do, right here. So this is the actual data that we've gotten. This is the predicted, right? How close is this number? 13.25 is relatively close to 13.72, right? So that was actually a pretty good estimation. The next question is asking us compute the value of the residual. And that's what you use to answer this question. Actual minus predicted. So your residual is computed by actual value minus predicted. And this goes for y. So let me say it like this then. Y minus y hat. Okay, not for x. A common mistake that I see students doing is doing it for x, but okay, if you do it for x, then it's the same value that you do. 6.45 minus 6.45 is 0. Okay, this really, think about it as the error that's made by the linear regression line. Okay, so compute the value of the residual. So the actual value for the price of beef was $13.72 minus $13.25, and what do we get? $13.72 minus $13.25, we get 47 cents. Okay, that's the residual. So what is the least square regression line is doing? Really what it's doing, it's computing these residuals for all of your sets of for all of your data points, and it's minimizing it. So it's finding this line that has the smallest errors. Okay, altogether the net error is very, very small. Well, it's the smallest, right? So because there's a couple of different lines that we could say would go through it and it would do a pretty good job of approximating it. So here's another line, right? Or maybe we could use this one. But your calculator is actually computing the least square regression line, meaning the error is the smallest. So it's the best line that we could use to predict rebuy price. Okay, so here's your residual, and this is pretty much covering the main concepts of 11.1 and 11.2. Now, for hypothesis testing, your chapter goes into many details and technicalities, and it gets a little bit confusing. So I don't need you guys to read 11.3 and 4. Just skip that all. The only thing that I want you to know is how to use your calculator to come up with conclusions about the slope of the line. So this one says, perform the hypothesis testing for the slope using alpha 0.05. What we're really doing here is the following. Your null hypothesis will always say beta 1 is equal to 0. What this really means, that means there is no linear relationship between the prices. That's what it's really saying. Okay? And your hypothesis testing for lines will always say stuff like this. Okay, beta 1, which is really the slope, is equal to 0. Okay, the null hypothesis claims no, the linear relationship is not existent, or it's not strong enough. Okay, then your alternative hypothesis will say either this, well, that's in our case because we took a look at our scatter plot and looks like the line is going up, the slope is positive, so it's reasonable to assume linear relationship is positive. Okay, sometimes it can say beta 1 is less than 0. That's if you have negative linear relationship, or other times you will see beta 1 is not 0. Okay, so what do we do? Okay, don't worry about the technicalities. All I want you to do is the following. Plug in your numbers in L1 and L2. They're already there. Okay, make sure that independent variable or explanatory variable goes in L1 and the dependent or response variable goes in L2. Then we're going to go to stat tests and scroll all the way down. You'll see Command F that will say linear regression t-test. Okay. X-list, independent, L1, Y-list, dependent, L2. Frequency, keep that 1, and then over here you select your alternative hypothesis. For our case, it's greater than 0. Okay. Calculate. And we get this p-value, right? 4.1129, so forth, e to the negative 4. Remember, this p-value is not 4. This is scientific notation. So our p-value is 0.0004, right? So 0.0004, that's a small p-value. We reject the null. Reject the null. There is sufficient evidence to claim that the linear relationship is existent and it's strong, right? So we reject this. There is linear relationship between the prices, right? Between prices of corn and beef. Okay, so the last question says, should we use the least squares regression line for part A to predict the ribeye price from the corn? Use the results from part B and C to answer this question, and the answer is yes, absolutely. We have 3 things that show the linear relationship is there and it's pretty strong. First of all, the scatter plot. Okay, so let me go ahead and mark 3 things. The scatter plot shows us that the linear relationship is there. We're not quite sure if it's moderately strong, if it's strong, if it's weak, but you take a look at it and you say, yeah, okay, I believe it. It looks like it's pretty linear. Then we have the correlation coefficient. That's relatively strong. Okay, it's close to 1. So that tells us that the linear relationship is strong and it's positive, right? So this is positive. So far everything is consistent. And then the last step, which is the most important thing, the hypothesis testing. Okay, this p-value is being very, very small. That means we have a very strong evidence to support the claim that the linear relationship is there. Okay, so is that a good model to use for predicting the prices of beef? The answer is yes. Okay, everything is consistent, everything is pointing to the fact that the line is good. It's a good model for predicting values. Okay, all right, I hope this was helpful for you guys. If you have any questions, don't hesitate to let me know. Email me with anything you need help with on the last chapter in this semester. Thank you for watching.